All right, notes today, solving equations. This is on page 45 or 59 of your toolkit. When you open up to this page, it might look slightly different as far as what's written on there. It definitely has equations, inequalities, and checking a solution. One of those pages has another thing squeezed in there. It's okay, don't worry about it. You're only writing on the side. And the checking a solution part we're going to talk about, and that's on both pages. So what I suggest you do is open up to that page, pause me, write down what I have written, and then when you're ready to keep going, start the video again. Because we're just going to do a couple of examples. So write that stuff down and then come on back to listen. Okay, so we're talking about two things today. I'm just going to give a couple more examples on equations because we've done a lot of these. And remember, solving equations is the same as solving inequalities. The steps are exactly the same. So we don't have to we're not starting from zero here. Now, the only thing that is new today that we maybe haven't talked about with when we were talking about inequalities was the first step, which is why I rewrote them, and that is eliminating the parentheses. If we have parentheses in the equation, they have to go away first. So I'm going to do a couple of examples over here, and I'm going to probably have to write small to make these fit. So if we have this problem, 3 times the quantity x plus 4 parenthesis plus 2x is equal to 42. I want to solve that equation. Now, first things first, we're usually like adding, subtracting first, looking for like terms, but we can't do anything until we get rid of those parentheses. And the way that we get rid of those parentheses is by using the distributive property, which, my friends, we've already talked about this year, is multiplying the number on the outside times each term on the inside to distribute that multiplication, which makes the parentheses go away. So 3 times x is 3x. 3 times 4 is 12. Now that plus 2x is still there, and equals 42. So rewrite everything I got. Now I'm going to start with that process of, I'm going to put my little dotted line there, solving the equation, right? Doing the same thing to both sides, all that good stuff. So step number 2 is combine like terms. Well, I do have like terms. I have 3x plus 2x together on the same side of the equation. So that's 5x plus 12, whoops, equals 42. Okay, so I'm going to clean that up a little bit. I kind of squeeze that in there. Okay, 5x plus 12 equals 42. Now, step 3, make 0 pairs by adding and subtracting. Remember, my goal is to get all the numbers on one side and x by itself. So I want that plus 12 to turn into a 0 pair. The opposite of adding 12 is subtracting 12 from both sides. That's why I drew the dotted line. Whatever I do to one side, I have to do to the other. There's a 0 pair. 5x is equal 42 subtract 12. There's 0. 4 minus 1 is 3. So 5x equals 30. All right, divide by 5. Last step is to undo my multiplication and division. Undo by dividing. Undo by dividing. And I get x is equal to 30 divided by 5 is 6. So there were my steps. Okay, that's all I had to do to solve that one. Now I'm going to put one more example here and hopefully I can fit it in. Okay, and then we'll talk about checking a solution. So this one, example number 2 right there, is this one's going to have parentheses 2. 4 times the quantity, x minus 6 is, close parentheses, equal to 6 plus 2x. Oh no, the dreaded x on both sides. First step, still distribute the multiplication so the parentheses go away. 4 times x is 4x. 4 times negative 6 is negative 24, right? A positive times a negative. And 6 plus 2x doesn't change. Gonna put my little dotted line here to remind me to do the same thing on both sides. Okay, now I'm going to make some zero pairs here. Remember, now I want both x's or all the x's on one side. Go to the smaller x and turn that one into a zero pair. That's the 2x. I turn it into a zero pair by subtracting. Got to do the same thing over here. That's 0 now. So 4 minus 2 is 2x, right? The x is still there. Subtract 24 equals, that's 6, right? We didn't do anything with that. Didn't change. All right. So now I have 2x minus 24 equals 6. Now I want that minus 24 to go away. To make that a zero pair, I add 24, add 24. Draw my little line. 0, right? That was my whole point there. So 2x is equal to 24 plus 6 is 30. Last step, undoing multiplication or division. This is 2 times x. I can't subtract that away, right? Because I want the 2 to go, the x to stay. If I subtracted it, the whole thing would disappear. That's not what I want. So I'm going to divide by 2 to make the 2 go away. 2 divided by 2 is 1, leaves x. And 30 divided by 2 is 15. Squeezing that in for my answer there. Okay, so I solved those two equations. Now, we talked about this in class. How do I check my answer once I have it? Right here, to check a solution, substitute the solution into the equation and verify that it makes the two sides of the equation equal, right? Plug it in and check. So we'll do this one, right? This one here, x equals 6. So I take that, 3 times, everywhere there's an x, I'm going to replace it with the value. I'm doing that first equation. So 6 plus 4, parenthesis, plus, remember, it's 2x, so 2 times 6. I could put the dot there too, but not an x because that's a variable, right? So 2x means 2 times x equals 42. All right, at this point, it's just order of operations. I can add that. 6 plus 4 is 10 times 3 plus, I'm going to go ahead and multiply that. 2 times 6 is 12. 10 times 3 is 30 plus 12, keep that there, equals 42. And 30 plus 12 is 42. So 42 equals 42. That's true. So that means yes, x is equal to 6. And remember, it was that one that I was checking, the first example, where I got x equals 6 is my answer. So that is every time, anytime you need to check an answer, plug your solution in correctly and solve it step by step. Remember, plugging it into the original equation. Those are your notes.